All right, we're back to tuned coax. Just a short little experiment. Got a VNA, 50 ohm shunt that's not perfectly 50 ohm. None of them are. Two 3-foot jumpers. One I made. One is some off the shelf, RG59 or something. So, made in USA. That's cool. And a tuned coax that I cut. It's not perfect, but I intentionally tried to make it perfect. Maybe I overshot it or undershot it when I made it, but a 12-foot jumper, half node, half wavelength. Tuned coax was untuned about 3-foot lengths. All right, got the load on there. So it's not perfect. 48.7, 1.03 SWR, 27 megahertz. Okay, I'm going to put this piece of RG400 on. Okay, I've got a 3-foot piece of RG400, same dummy load. We're now at 46.5 ohms, 1.08 SWR. Well, how did it do that? Coax doesn't set SWR. Coax doesn't affect SWR. So what everyone keeps telling me, coax doesn't adjust anything. It's coax. It's just coax. It doesn't adjust anything. Okay, so now I'm gonna try a different piece of 3-foot coax. All right, now I got this other piece of coax, USA made. It's gotta be better. It's gotta be the same. Shouldn't affect anything. Whoa, 1.23 SWR, 42 ohms. What's going on? Why is this coax making my SWR change? That's weird. 42.6, 1.24. But it's just coax. Coax doesn't affect SWR. It's what like 20 people have said to my first video. Coax doesn't affect it. You don't know what you're talking about. It's blah, 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 blah. You're wrong. Tuning coax is a waste of time. Then don't waste your time. If you don't have a problem with it, don't waste your time. I'm going to put my 12-foot coax on now. It's tuned. Okay, got my 12-foot piece of coax here. It's not coiled up like a nothing. 49 ohms, 1.04. Huh, so it's almost like it doesn't even recognize this coax is on there, because it's only like made the minorest amount of change. I think the original SWR was 1.03. So coax, even though I intentionally tried to tune this, I don't remember what frequency I tried tuning it at though. It's 27.2, somewhere in the middle. Somewhere around here is where I tried tuning it, I'm sure. My MFJ. It makes a difference. Just like when you look at it, as the frequency changes, it changes. It's almost like the frequency has something to do with the inductance and reaction and the tuning of the coax, or vice versa, right? Because it doesn't look like a totally flat picture there. Looks like the SWR and the resistance kind of goes up and down in, like, I don't know, nodes. To be perfect, it kind of looks like this one was tuned to be perfect at 23 megahertz. Well, I probably right there, 25.3 megahertz. Right? So maybe I cut it, an inch too long or an inch too short or whatever, or I had a different barrel on it, the different brand barrel. But whatever. The coax length affects the tune. It doesn't affect your SWR. Your SWR is set by the load, right? That's the antenna. But it can affect how the circuit tunes out because you're adding inductance and capacitance. That's the only thing that makes 50 ohm coax 50 ohm, or 75 ohm coax 75 ohm, or 100 coax ohm 100 coax, or 100 ohm coax 100 ohm. It's how much capacitance and inductance that these add up to be to equal your resistance. This doesn't have any resistance. It's a resistance that's created through an inductance and capacitance. If I take a piece of wire that's not shielded and I need a jumper inside an amplifier or a radio, if I want to make that wire act invisible, I would take a shunt capacitor to ground, and then it would simulate a piece of coax. So that's how you tune the inputs and outputs of your amplifiers, is you add inductance or capacitance to make it invisible. You tune it. Well, coax is just nothing but an inductor and a capacitor. So depending on how you're using it, it can affect the tune of your antenna circuit. It doesn't change the tune of your antenna, but it sure does affect the circuit. Minimally, maximally, depends on how off your jumpers are. Maybe if this was a 4-foot jumper, it would do something different. Or heck, these are both almost exactly the same length, but one's got a velocity factor of 1 and the other one's got a velocity factor of something else, and it changes it. This is a nylon insulator and this is a foam insulator. That changes the capacitance. That changes the reactance. It changes the tune. Even though those are the same length. Like almost within an inch. So, this is my findings. Can't wait to hear what everybody says.